Hi, welcome. This video is for the last homework set. So I believe this is homework 4. And for chapter 4, volume, and 3D. Now my paper looks a little different because I didn't bring home the sheet, but it should pretty much be as close to exact of the sheet you have. I just didn't bring home the copy and I had an electronic version. Okay, so question 1 says, write out all the volume formulas. Notice 2 P's, 2 C's, and an S. Yes, you should have these memorized. So you might want to write them out on another piece of paper or just here on the margin. 2 P's, 2 C's, and an S are prism, pyramid, cylinder, cone, sphere. Okay, so the volume formulas you would use on the test would typically be base times width times height if it's a rectangular prism. Pyramid, base times width times height divided by 3. Cylinder, pi r squared h. Cone, pi r squared h over 3. And sphere, this one will be provided to you, 4/3 pi r cubed. Now the formulas that will be provided on the test and on the midterm and on the EOC are these. Okay, so these are the ones provided. Notice that that's why we've been working on memorizing these, because these are the ones you actually need to do the problems. These are to help you remember these formulas. And this that's inside the box is what's provided. So let's get to work. It says the volume of the prism. So the volume of anything in the universe is the area of the base times the height. Now we're noticing that this is a prism, so it was made by stacking triangles. So the base is actually a triangle, and it looks like you stacked those triangles 17 meters high. So the base here is a triangle. Now we notice up here that this is a right triangle, and that's important because the area of the base is a triangle, and that's base times altitude divided by 2. And this formula was from the last chapter. So our base is 1, and our altitude, boo, splat, is 2. So our base is 1, our altitude's 2, and we have to divide by 2. So that would give us the answer 1. So the area of that triangle is 1. The area of the base is 1. And the height, I stacked it, would be 17, 1 times 17 meters cubed. Awesome. Now next it says, find the height of the cylinder. So notice I'm not solving for the volume. I'm actually solving for the height, which is a little bit different. That's interesting, isn't it? So the volume of a cylinder would be pi r squared h if you had that memorized. See it here. Because it's made by stacking circles, and that's the formula for circle. So let's fill in what we know. Using substitution, I could substitute 271.4 for V. Pi is still pi. The radius is 6, so I'm doing 6 squared, and the height is, I don't know. So I asked myself, using algebra, what is keeping h from being by himself on one side? And I noticed that maybe it would be helpful if I rewrite this. So I'm going to rewrite it. 6 times 6 is 36. And I still have my pi and I have my h. And so I'm noticing that it's the 36 pi that's keeping h from being by himself. And if I could divide by that, then it would cancel and h would be by himself on one side. So if I go ahead and do that, this problem is difficult just to figure out how to type it in the calculator. It's really the same steps using algebra. So the height would be 271.4 divided by 36 pi. So to type this in the calculator, the height would be 271.4 divide by 36 and hit equals. And then divide by the pi button and hit equals. And that should get us our final answer. Okay, so let's take a look here. 271.4 divide by 36, enter. Okay, and that's what I get. And then divide by pi, enter. And the direction said round to the nearest tenth. So I'm going to write 2.4. So I get 2.4 inches because that is my height. Now I can double check this answer, plugging it back in. So here we say to ourselves, okay, the volume of anything in the universe is the area of that base times the height. So if the radius was 6 squared, and h, we think h would round to 2.4. So we could redo the problem. 2.4 times 6 times 6 times pi should give us this answer to double check it. So let's do it. 2.4 times 6, enter, times 6, enter, times pi, enter. Ooh, 271.4. So I actually double checked my answer. Bing, bang, boom. There we go. Now let's look. This is a composite. So that means I have two shapes. I just need the volume of this item. And that's a prism. And that's this generic formula, rectangular prism. Just take base times width times height. So 2 times 5 times 6. 60 centimeters cubed. Now this object, so what makes this problem tricky is it's kind of blocked. So that's kind of interesting. And this is where our efforts for drawing help us out. So it looks like this line is parallel to this line. So the green box that's kind of hidden by the black box looks like it is 8 by 3, and this dimension would be 5. So the volume of the green box would be base times width times height, and it would be 5 times 3 times 8, and so that'd be 40 times 3, 120 centimeters cubed. So the composite shape would be adding these together. Now, most of these are a little harder than what is on the test, but it definitely will get you ready for it. So again, I'll point out which questions are more like the test questions, but let's just keep working here. So I got 100, the total object would be adding these together, 180 centimeters cubed for the composite. Okay, now it asks for us to leave this in exact form. That would be leaving the pi and making sure not to round anything. Now I do think I have to make some assumption. I'm not given the dimension on the bottom, so I'm going to assume that the bottom is a square. Okay, now this one's more difficult than the test, but it's a great practice problem. So the bottom is the volume of anything in the universe is the area of the base times the height. So the base is just a square, so base times width. And then how high did I stack it? The problem here is I'm not sure how high. There's no altitude written in. So base times width times height, divide by 3 if it's pointy. And it's definitely pointy because it's a pyramid. So again, this pyramid formula is helping me out. And I know that the base and the width, I'm going to assume it's a square. So the base and the width are both 12. But the height, I don't know. I'm not sure. They gave me the slant height. Now I'm going to explain the reason why we could know in this instance. It looks like they didn't give us any information. But let me draw a right triangle inside my pyramid. And notice that if we make a dot in the middle of our base, and we know this is a square, then if this whole thing is 12, in a weird way, we know this is 6 feet. Okay? That wouldn't just be a complete assumption, because if it's a square, that dot should land in the middle. We also know that's 10 feet, because they gave us the slant height. So I can use algebra to solve for h. So this would be Pythagorean Theorem, and this is a very interesting problem. You might not see it on the test, but you might see it on a cycle assessment of some sort. So a squared plus b squared is c squared. In a right triangle, you can use the formula. So one side is 6 squared, one side we called h, and the hypotenuse we called 10. So I get 36 plus h squared equals 100. So right now, 36 is keeping it. So I'm going to subtract 36 on both sides. And I get 64. Ooh, I'm thinking I'm figuring something out here. It looks like my height needs to be 8. And so I actually knew without doing the math, because this is the most famous triangle. So watch the next video and we'll pick up right where I left off. Thanks for joining us.